Welcome to The Explainer. Today, we're getting into an introduction to VLANs and taking a look at exactly how we can split physical hardware using nothing but software. Okay, let's dive right into this. Have you ever actually stopped to think about the invisible architecture that's powering our everyday digital lives? Every single time you send an email or stream a video or make a secure online payment, your data is traveling through this vast, incredibly complex maze of hardware. But here's the thing. The physical wires and those metal boxes you can actually reach out and touch, they're really only half the story. Today, we're exploring the ingenious software magic that keeps our networks organized, lightning fast, and secure. We're looking at VLANs. To really wrap our heads around why this technology is just so vital, you have to ask yourself a pretty scary question. What actually happens when a highly sensitive bank server and a random guest smartphone share the exact same space? Just imagine a standard network switch. Now plug a bank computer, a public visitor's phone, and maybe a building security camera all into that exact same box. Without any specific configuration to sort them out, these totally diverse devices are basically just thrown together into one giant virtual room. They are literally screaming over each other, creating these massive waves of data that constantly clash and mix together into a really messy, chaotic cloud.
And when you leave a switch unconfigured like that, you create what network engineers call a flat network. And the consequences of a flat network? They're pretty much immediate. In this setup, every single device can intercept and talk to every other device on the line. Think about what that actually means in practice for a second. Allowing a public guest on the Wi-Fi to mingle in the exact same network space as a bank's central server is, well, it's an absolute recipe for disaster. This complete lack of isolation leads to incredibly crowded, congested data traffic. And of course, that congestion instantly results in low network performance. We're talking slow speeds across the board. But honestly, far worse than a sluggish connection are the incredibly high security risks. Anyone with just a little bit of know-how could potentially snoop on highly sensitive financial data simply because, digitally speaking, there are zero walls protecting it. We desperately need isolation.
So the crucial point here is, we need a way to build those walls, right? But we want to do it without having to go out and buy separate, super expensive physical switches for every single group of users. Enter our elegant solution, the VLAN, or Virtual Local Area Network. A VLAN gives us software-based separation right inside the physical switch's configuration. It relies on this brilliant little trick where it essentially forces one single piece of physical hardware, the actual cables and the ports, to act like multiple, completely independent virtual switches. Imagine taking a 3D model of a network switch and just slicing glowing, transparent colored walls right through the middle of it, separating those physical ports into entirely independent zones. That is exactly what a VLAN accomplishes, entirely in the software. It kind of helps to compare this to an office building. Without VLANs, what you've got is a totally chaotic open floor plan. You've got accountants handling payroll, security guards monitoring their cameras, and random public visitors all just sitting in one giant open room, shouting over each other. Anyone could just casually walk over and peek at confidential files. It's noisy and it's dangerously exposed. But inject VLANs into the mix, and suddenly, boom, solid concrete walls drop into place. The accounting team is securely locked behind room 10, while the public guests are completely isolated over in room 20. They are still sharing the exact same physical building structure, but now there is total privacy, strict security, and finally, some peace and quiet. Let's look at how this actually translates to the physical hardware layout. Remember, it's the exact same physical hardware box, but it's operating as two completely isolated worlds. Logically speaking, we can map ports 1 through 8 to, let's say, VLAN 10 for our accounting group. Then we map ports 9 through 16 to VLAN 20 for our guest Wi-Fi. Even though all of these cables are physically plugged into the exact same metal box sitting in a dark server closet somewhere, as far as the devices are concerned, they are on entirely different planets. The guests hanging out on VLAN 20 are completely invisible to the accountants working on VLAN 10 and vice versa. Now you might be wondering, just how many of these isolated virtual rooms can we actually build? Well, the magic number is 4,094. That's the total number of available tracking IDs that network engineers can deploy to create these separated virtual networks on a single standard switch. You literally have over 4,000 independent rooms at your disposal to slice and dice your infrastructure. It perfectly fits the needs of any organization, no matter how massive or complex the deployment gets. So, how does the hardware actually manage to keep track of all this separation at lightning speed? It pulls this off using something called the 802.1q VLAN tag header. Yeah, it's a bit of a mouthful, but honestly, just think of this tag as a hidden digital sticker. Whenever a piece of data, which we call a packet, enters the switch instantly injects this header into the packet. It is literally slapping a brightly colored digital sticker right onto the data, permanently assigning it an ID anywhere from 1 all the way up to 4094. And here is exactly how that hidden sticker works in practice. Step 1. A clean data packet enters a specific port on the switch. Step 2. The switch instantly slaps a glowing digital tag onto it. Let's say it's VLAN ID 10. And step 3, from that millisecond onward, there is an absolute unbreakable rule. The switch will only allow that packet to exit through ports assigned to that exact same ID. If that packet tries to wander off and exit through a port labeled for VLAN 20, no way! The switch throws up an invisible shield and hard blocks it. Traffic labeled with tag 10 will absolutely never be allowed to cross boundaries into VLAN 20 territory.
Let's zoom out from the micro level of those packets for a second and look at a real-world enterprise scenario. Picture a massive server rack down in the basement of a sprawling commercial skyscraper. This rack connects every single floor. You've got a bustling, high-traffic retail office up on the 3rd floor and a highly secure financial bank on the 4th floor. Now, these are totally different businesses, right? But they actually share the exact same physical switch down in the basement to get their internet connection. Because we have VLANs, you can securely connect both businesses. This logical separation guarantees that retail workers furiously hunting for backroom inventory on their system can't see a single byte of the bank's highly confidential wire transfers. And this brilliantly illustrates another massive reason telecom operators rely so heavily on VLANs: service control. In what's known as a standard triple play deployment, a single fiber line running to a home or a business delivers 3 things: internet data, IPTV, and VoIP phone service. A field technician is running all 3 of these clean streams of data through the exact same physical fiber cable. But to keep the entire network stable, they absolutely must be neatly color-coded and separated into their own dedicated VLANs. Why is it so absolutely crucial to isolate these specific services? Well, because their traffic behaves entirely differently. Everyday internet data generates heavy, totally unpredictable bursts. IPTV, on the other hand, relies on continuous multicast traffic that, if it's left uncontained, can easily flood and completely freeze a local area network. And VoIP, it's incredibly delay sensitive. I mean, just a few dropped packets and your phone call becomes totally unlistenable. By using VLANs, we're giving each service its own quiet, isolated virtual lane. This practically guarantees that someone's massive file download won't suddenly crash a sensitive digital phone call happening in the very next room. They share the same cable, but they never, ever cross paths. So the next time you connect to the network at your local coffee shop or stream a show in your living room or securely log into your workplace server, take a second to think about the silent, software-based architecture working overtime behind the scenes. It's a brilliant system of logical chopping, hidden digital stickers, and incredibly strict invisible boundaries that literally turn a single piece of hardware into a fortress of isolated networks. Which leaves us with one pretty fascinating thought to end on today. Take a look at your own devices right now. How many invisible walls are protecting your data at this very moment? Thank you so much for joining me for this explainer, and I'll catch you in the next one.